Hello everyone and welcome to this video. In this one, I'm going to show you how to install C++ for use inside of Visual Studio Code, and we will be using the latest tools, the latest standards. Everything is going to be really cool. Let me show you what you can do. Here I have a project opened. You see we have a main CPP file. We have a person class that we are using. Inside the main CPP file, there's a lot happening. You see we have a person object, we have a point object, and the point object is going to be using the three-way comparison operator. This is something from C++20. We want to be working with this project, running applications, debugging, and doing all kinds of crazy things. Let's try to compile this. And one thing I will show you is that we can use different compilers. A really good thing to do if you are a professional C++ developer, you need to test your code at least against two compilers, and I will be showing you MSVC and GCC in this video here, so you are in luck. Let's try to compile with MSVC. To compile, you come to terminal, choose run task, and choose whatever task you want to use. We have a task which is going to be using the MSVC compiler and a task that is going to be using the GCC compiler. Let's start with GCC. We can choose that. Okay, you see the build is successful. If we want to run the application, we can go down on the terminal and run it. We know it is named Rooster. It is going to do whatever it is we are doing in this application. Notice again that the application is using C++20, which is really cool. We can also build using the CL compiler. So if we do the same thing, do terminal, run task, and choose the CL compiler, you see that we will be calling the CL compiler on the terminal. It is going to build and link our application. The build is going to finish successfully, and we can run the application again. And you will see that everything is working here. This is not all. We can also debug the application. You should be able to debug your C++ application. To debug, we come in the main.cpp file. Suppose we want to see what is inside this person object and what is inside this pt1 object, which is a point object. We can set up a breakpoint on line 33 here, and to set up a breakpoint, you come on top here and you see that we have a dimmed down red point. Click here and the point is going to be anchored here and it's going to be really red. Now that you have this, you can hit F5. This is going to kick off your debugging process. The binary is going to be built. It is going to be plugged into the debugger, and we will hit our breakpoint, as you can see on line 33 here. And once we are at the point, we can hover over anything and see the data inside. For example, we can hover over PT1. You see we have X and Y. We can hover over S here, and we can see things inside. We can hover over person here, and we can see that it is an empty object, which is really sad. But we can do all kinds of crazy things. Now we have kicked off our debugging process. We can step through things, and we can see things coming to the output as we navigate through our application. This is what you will be able to do after you have set up your C++ environment inside of Visual Studio Code. So let's do this. Okay, we will do things in 3 steps. We will install the compiler, we will install Visual Studio Code and the extensions that it needs, and we will start configuring our project to work with C++. You can use a lot of compilers on Windows, but in this video, I will be showing you MSVC and GCC. Let's start with MSVC. Once we have it working, we will move on to set up the GCC compiler. Okay, let's set up the Microsoft Visual C++ compiler, and we will be using this official tutorial to guide us through the steps we need to follow. For example, you see that you need to have a Visual Studio Code installed. We will install it later. Now we want to install the compiler. You need the C++ extension. Again, this is easy. Now what we want to do is to install Microsoft Visual C++. And you can install it following the steps that we have here. I want to go through this. Just go to the site, download Visual Studio, install it. You have to click on desktop development with C++, and you need to click on the install button, which is going to start installing Microsoft Visual Studio on your compiler. Mind your steps. MSVC is a big beast. You see that here, it's going to require 8 gigs on your system. So make sure your system can handle this and install it. It is a good compiler. After you have it installed, they say, how do you check that it is installed? You need to go to the start menu and choose developer prompt for whatever Visual Studio version you have installed. So let's do that. We can come here and say developer, and you see that on my system here, I have developer shell developer PowerShell, and developer command prompt for whatever version of Visual Studio I have installed. I have a Visual Studio 2022, and I recommend you install the latest you have access to. At the time of this recording, Visual Studio 2022 is the best I can do, but make sure you can do whatever is allowed by the time when you watch this video here. Now, let's do that. We're going to developer, and I am going to choose PowerShell because I can. It is supported on my system here. And they suggest that after you have it, you run the CL command here. So let's do that. We can CL on our system, and you see that we have output. This means that you have the Visual Studio compiler that is required to build C++ applications on Windows installed, and this is really cool. Now that you have this, I will show you how to install the MinGW compiler. Again, if we go on the left on our documentation here, you see that they say that we can also do GCC on Windows. I am going to open this up, and again, they give us the prerequisites. We need Visual Studio Code and the extension. But here, they say that you get GCC through the MinGW 64 toolchain. And they recommend going through MySys2, which is something I don't like. There is nothing wrong with it, but I prefer to use another way that I am going to show you, which is way easier. So open up a new browser tab. In your search engine, type WinLibs, and you will get a link here, winlibs.com. If you open it, you see that it is a guy who gives us installations we can put in our system, and everything is going to work. If you go down, you see that they say MSVC RT or UCRT. These are things that confuse people the first time you try to use this thing. And they give it advice that unless you are targeting older versions of Windows, UCRT is a better choice. So UCRT is what we want to use here. If you go down, you see they say UCRT runtime. This is what we want to use. You see they provide GCC 13, which is very new at the time when I am recording this video. And they even give you options to download LLVM and Clang, which is mind-blowing. This is really cool. So we are going to pick the version here, which is going to install GCC and Clang for my Windows 64-bit version. So I am going to download this zip archive, and I will extract that. Make sure you download whatever applies to the system you have. If you are on a 32-bit version of Windows, you will grab the Win32 version here. But I am going to grab the zip archive, which is going to give me both GCC and LLVM Clang. I am going to wait for this to download, and I will extract this somewhere on my system. Okay, my download is done, and if I go in my download folder, you see that I have this thing here that I can extract. I will extract it and put this MinGW folder into my C drive. So this is what I am going to do. I am going to go on my C drive and put that MinGW folder that I extract in my C drive, exactly as you see here. And if you go inside, you see we have a bin folder. If we go in the bin folder, we have our compilers. You can see we have Clang and Clang++. If you go down, you see that we have GCC and G++. These are compilers. And after you have this extracted in your C drive, make sure you grab the path to the bin folder, which is right here. I am going to copy it and hit start and do environment variables and go into the settings for my environment variables. I click on environment variables and I go to the system variables. You can, by the way, put this in user variables, but I am the only one using this system here. So I can go in my system variables. This is my preference. Go to path and click new and paste in the path to your bin directory inside your MinGW directory and hit OK. After you hit OK, that path is going to be available for use. I already had that path in here. You can see that I already had it. So I am going to remove what I just added because I don't need it. But you need to keep that in place if it is the first time you install this thing here. Now let's go back to the documentation. After we have MinGW installed, how do we check that we have it installed? You see, they have a section on check your MinGW installation. Open a terminal window. So we are going to do that. And you need to do GCC -- version. If you see a version output, it means that you have GCC installed. do G++ version, and you see a version printed out here. You also need to do gdb -- version, and it is going to give you output, meaning that you have these things installed. Now we have completed the step to install the compilers. We have MSVC installed because we can do CL on the terminal. I think we did it here. Okay, we can do it and see output as instructed by the documentation. We can also do the check to see if we have GCC installed through the terminal here. Everything is working fine. Now we can move on and install Visual Studio Code and the extension that is required by the documentation that we do here. To install Visual Studio Code, you click on the link here. They will take you to where you can download Visual Studio Code. We will download it for Windows. I am on a 64-bit version, so this is what I am going to download here, but you can download whatever applies to the operating system that you are working on. After you have this downloaded, click through the installer. The installer is going to be somewhere in your download folder. Click on it and start installing Visual Studio Code. Make sure you add it to your path if you are given the option to do that. That's going to make sure you can run it from the terminal, which is going to be really cool. After you have Visual Studio Code installed, you will see it in your start menu, or you can even say Visual Studio, and you will have an option to run Visual Studio Code. Okay, now that we have this, we need to go through the terminal that came with our installation for Visual Studio to be able to call these compilers inside Visual Studio Code. If that doesn't mean anything to you, don't worry, just follow the steps I am following here. So go to the start menu, do developer prompt, and hit developer PowerShell. This is the first step. Now that you have this, you can say VS Code and hit dot. This is going to open Visual Studio Code in this location here. Let's again say VS Code dot. We need to say code, not VS Code. Sorry, my bad. And after you do that, Visual Studio Code is going to be opened. And in my case, it is opening some things that I did earlier, but it doesn't matter what it opens here. Now we have a Visual Studio Code instance that can call the compilers that we have installed on our system. I want you to do this check here. Make sure you can say cl.exe. It is going to give you output concerning your information. Okay, and if you don't see this terminal, just go to view and say terminal, and it is going to show up on your Visual Studio Code instance that you just installed. We also need to check that we have G++ version working here, and we can do even Clang, but we're not going to be using Clang here, but we have it installed as a result of installing the WinLibs binaries that we downloaded. You see, we can use Clang, but it is not necessary for what we are doing in this video here. Now that you have this, set up a folder on your system. I am going to go in my sandbox folder and set up a folder in which I'm going to set up a project which says tasks Windows. I am going to nuke everything I have inside here because we will be starting from scratch. So make sure you have a folder in which you will be storing your project and drag it and drop it on top of Visual Studio Code. It is going to be open up in your project here. And now we are ready to start creating C++ files that we would like to compile inside of Visual Studio Code. Again, we can go to the documentation and see what they are saying here, where they say create hello world. They say to go in a folder and create a bunch of C++ files. We will be creating our main.c++ file here. So let's do that. Main.cpp. Click on the plus button and type main.cpp. And just to start out, to do something fun, we will go to cpp reference and check for default comparisons. And we will have a code snippet that is going to be using C++20. So I am going to copy this. You can find the link to this in the description below, but you can also search this on your own inside your search engine. And I recommend you do that because you need to be able to search things on your own. We have a main C++ file that we want to compile. Okay, how do we do that? Let's go to the documentation again for MSVC. And they say that we need to add a source file. We already did that. We're not using the code they use because we want to try things for C++20 in a minute. You can also enable autosave to automatically save things. To enable autosave, you come inside your installation of Visual Studio Code, and I don't think this is what we want. We want this one. You come to File and select autosave here. Make sure you have a checkbox checked before autosave here. This is going to be autosaving your files. This is what they say in the documentation here. You can explore IntelliSense, so you can come in here, for example, and say point pt1 and hit dot. You see that we have autocomplete. This is really cool. You can try this out. This is what they are saying in the documentation here. But what we want is to run this thing inside of Visual Studio Code. And they say that to run, you have to open the CPP file so that it is the active file, and you need to press the play button in the top right corner of the editor, which is what we have here. We can go inside of our Visual Studio Code instance and click on that run button. And if we do that, it is going to trigger Visual Studio Code to scan for the compilers that we have installed on our system. And you see that we have a bunch of compilers. Some are coming for the MSVC installation that we did. Some are coming from the WinLibs installation that we did. In this case, we want to do things for the MSVC compiler. So we can go all the way to the bottom and select cl.exe here. Make sure you select it. If I select it, things are going to fail a bit because our code is set up to use features from C++20, and Visual Studio Code is not configured for that by default. Not to worry though, we can change that. I am going to go to my Git repository and steal a few things that we need to set up here. I am going to steal a flag that we need to give to Visual Studio Code inside the file that is generated by us trying to run the application. And one thing I should point out is that when you click the run button, Visual Studio Code is going to automatically generate a tasks.json file for you. And this file is used to tell Visual Studio Code how it's going to be compiling your application. It is basically the interface between Visual Studio Code and the compiler. Let's open this file, and you see that it is specifying that we are using the MSVC compiler, which is named CL, and these are the arguments that we are passing to the compiler. What we want to do is to change these arguments to mean that we want to use the best C++ standard available, and you say it by saying std:/C++ latest, as I am showing you here. This is the thing you need to put in place. Now we can close this file, but before you close it, you can look at it. For example, if you go down, you see that it is configured as the default setting to compile stuff inside our project here. So by default, we will be using this MSVC compiler. If you want, you can check this in the documentation, or you can even go in the tutorial and see what they say about this task.json file here. But now that we have this in place, we can select our main.cpp file and hit the run button again. Let's do that. Okay, you see that compilation is successful and the thing is running, and we have output from our application. You see that it is going to be outputting false, true, 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 false. And you see false, true, 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 false, false. It is exactly what we expect, and our application is compiling inside of Visual Studio Code, and this is really cool. Okay, now we can compile and run applications from inside of Visual Studio Code. After you have the application compiled, you see that we have generated the executables that you can see on the right here. This is what we are running inside of our project. If we do ls to see what is inside here, you see that we have a main.exe executable that you can run manually, and you will see the output. This is something you can do. Now, one thing I don't like is that our project has a bunch of squiggles, but not to worry. This is happening because Visual Studio Code is not configured to pick up IntelliSense from the latest compiler that we are using. To change that, click on View, Command Palette, choose Edit, the thing that says C++, Edit Configuration UI. You need to go to this thing, and this is where you configure a few settings. And one of the important ones is the include path. For example, you can come here and specify directories that contain include files that you want to include in your C++ program. So if they are somewhere else on your system, you can add their paths here. You notice that they say workspace folder -- this is going to include anything that is inside of our project here. But if your files are coming from other places, you may add them here. And again, there is a short documentation here that you can read. What we want is to set the C++ standard that is used by our project, and we want to set up C++23 because we want to use the best, we deserve the best, and we will use that here. After you set this up, this is going to generate another file in your VS Code folder, and that's going to be the cpp properties.json file. We can close out of this and open that file manually. You see, it has a bunch of configurations here. I'm not going to explain them all, but the important one is that we are using the C++ standard of C++23. And after we have this set up, you see that the squiggles are gone because now Visual Studio Code knows that we are using the best C++ standard we can get our hands upon, and it's going to work. This is really cool. Let's go back to the documentation again, and I think there is a few things they tell us that we need. You can read through this to understand what your configurations are doing. Reading the documentation is one of the best things you can do for yourself. Here they say that we can modify our tasks.json file to build multiple files if we want that. This is something I like to do. So I am going to take this and copy it in my clipboard, and I am going to replace this and not use the file property anymore in my tasks.json file. So let's go there and take out the file thing and paste in the new thing we got from the documentation. Another thing I personally like to do is to hardwire in the name of the generated executable. I am going to name mine Rooster because that's what I like to do. When I close out of this and go back to the location where I have my project in, so I think it is this place here. Okay, so this is the project. I can delete the files that were generated by my previous builds, and I can try to build again by coming to run. Now it is going to be using the configuration in the tasks.json file. And notice now that it has generated a binary named rooster.exe. And this is really cool. Now, I have shown you how you can run the application, but we haven't debugged the application. To debug, the first thing you need to do is to set up a breakpoint. So I will go down here and set up a breakpoint on line 17 after we have the point object. So this is what we want to expect, for example. And after you have your breakpoint in place, come to the button here and click and choose debug C++ file. If you do that, this is going to call the debugger. This is going to build your project. It's going to generate the binary, and the binary is going to be plugged into the debugger, and we will be hitting our breakpoint here. Once we hit the breakpoint, you can inspect things in our application. For example, we can hover over PT1 to see what is inside. You see that it contains 2 member variables, and we can really do all kinds of crazy things. On the left here, we can see the local variables. We can see what is inside. And the most important thing, in my opinion, is to be able to step through the application and see things happening. But of course, you can also set up watches and see things happening in your application. Again, if you want to learn more about debugging, please come to the documentation here and see what they are saying. It is exactly the same information I am showing you, but I am showing you some new things you can do on top of what the documentation says, because we deserve best. So now we can debug, we can do all kinds of crazy things, but the debugging is kind of hardwired in, and we can't really influence how debugging is happening. For example, we can't pass command line parameters to our binary if we happen to need that. So if you need to do that, you need to set up a configuration file that is going to be used by your application to debug stuff. And it's not really hard to do that. All you have to do is click on this gear icon in your installation of Visual Studio Code. So hit it, and it is going to pop up a bunch of compilers from which we can select which one we want to use to do debugging. We will be using the one for the MSVC setup we did earlier. So let's select that. And after you do that, a file is going to be generated inside of Visual Studio Code, and it is going to be a launch.json file. You see, it contains the configurations that will be used to debug our application. You can read more on these in the official documentation. They talk about debugging, but the most important one, in my opinion, is this one, which is going to link this debug configuration to a launch configuration we have in the tasks.json file. And it is going to be matching what we have in the label here. Make sure you can see that. So what we have in the label here has to match with what we have in the launch.json file under the pre-launch task property here. Make sure these two things are matching, and you see that they even picked up that we want to be launching the Rooster executable because it is what is built into the tasks.json file. This is something you need to know. Now that we have a debug configuration in place, we can go in the main.cpp file, set up a breakpoint, and just hit F5 to start debugging. And this is really cool. This is how you should be debugging your applications if you are doing things the way we do them in this video here. Now we have hit our breakpoint. We can step through the application, and as the application runs, you can see output. For example, step over, you see we have the output. We can inspect the local variables. We can do all kinds of crazy things. And this is really how you should be using Visual Studio Code in C++. We have done things using the MSVC compiler, but that's not the only compiler you can use inside of Visual Studio Code on Windows. Another compiler we have configured and set up in our project is the G++ compiler, and we can use it. For that, we can go on the configuration for the GCC compiler, and we can follow the steps to try and use that compiler. And it is going to also generate things you can do in the tasks.json file and the things you can do in the launch.json file, which is going to be using by your debug configuration. What I am going to do, I am going to copy the configurations that I have set up. So you see, this is a tasks.json file. This is a launch.json file that we can use. Let's copy the G++ compiler configuration that I have in my project here and copy it. And again, I will be providing these links in the description below. You can go to the Git repository and pick them up and use them and copy and paste them like we are doing here. I am just copying and pasting to save on time because I don't want you to watch me do the thing we have done before. So what I'm going to do is to come in our tasks. You see, it is a JSON array. We can go to the first object here, put a comma in, go on the last line and paste in the configuration for G++. You see, it is using the G++ compiler. It is using our MinGW installation, and we set it up for using C++23. Again, because we deserve the best. It is going to be building a Rooster binary, and it is going to be compiling every C++ file in our workspace folder, which happens to be this folder here. Okay, the things we have inside our tasks Windows folder, this is our workspace folder. So it is going to be compiling every C++ file it finds inside this workspace folder, and this is really cool. Okay, now that we have this in place, we can also change our launch.json file to use the same thing. So I am going to go inside and pick that up in the launch.json file, and we have the thing already selected. So let's copy it and put that in place. Launch.json, go to the first object, go to the end, put a comma, go on the last line and paste in the configuration. And again, this is going to be using the debugger inside here. It's going to be running the Rooster binary. Everything is going to be set up. This is what we can do. Now we have configurations we can use to do things either using the MSVC compiler or the GCC compiler, and this is really cool. So now that we have this, we can close our VS Code folder, make sure the main CPP file is selected. And how do we compile it with whatever compiler that we want? Well, you can come to terminal, run task, close the things we did earlier. Now you see that we have the option to build with CL or G++. Let's build with CL, and it is going to tell us that what is happening here. It is going to say that it doesn't know about this operator. Let's go back to our tasks.json file and make sure that cl.exe is using the latest configurations. Point does not define this thing. It should define that thing because we built this earlier. So let's make sure this is selected and terminal, run task and choose the CL compiler. Now it is going to build successfully. I don't know why it didn't, but if we want to change the compiler, we can do terminal, run task, and use the G++ compiler. It is going to build successfully. Everything is going really fine. If you want to change the debug configuration to use G++, you can click on the status bar here and choose that you want to use G++. It is going to be selected here, and it is going to be what we use to do our debugging. Another way to do that is to come to the debug option here and choose G and G++. Either way is going to work for you. Now you can use MSVC and GCC inside your Visual Studio Code installation. This is really cool. Okay, if you want to set up multiple files in the project, you can do that. So let's make sure I show you that before I close off this video. For example, you can set up a person.cpp file and a person.h file. And in h, you can say pragma once to make sure that we are not processing the same file multiple times. Okay, let's go to the code and grab the code really fast because I don't want to waste your time typing this. So we can put in the person class in the header. Again, it is a simple person class. We have, I put in the wrong file. This is the CPP file, and I should be giving you the header file. Let's make sure I can find the header file. It is right here. So let's put in the code. Sorry for that, but errors happened. So this is not a big deal. We can select everything here, delete, and put in the code for the header. And we need to put in the code for the CPP file. Again, we go there and grab it, the code for the CPP file, put that in place. And we can go in person.cpp and put that in place. We can go in the main.cpp file and include person. We can do that. So include person.h, and we can create a person object down here. So person p1, and we can say p1.eat, for example, and the person is going to eat. Let's hit tab to autocomplete this. We can recompile the application. So terminal, run task, build with whatever compiler we want to build with. Let's use GCC this time. And if we run the application that was built, for example, we can come to the terminal and run rooster. And you see that it is saying I am eating because it is the second thing we output here. If we want it, we can put a new line character after we do the other thing. Okay, for example, I think this is going to do, and we need a semicolon, of course. Let's rebuild using the CL compiler, and we can go down and clear and run rooster, and it is going to say I am eating on the next line. This is really all I had to share in this video. You saw that you can use different compilers. Now we can use MSVC. We can also use GCC. We can use the C++ extension. And we saw that we configure stuff through the tasks.json file and the launch.json file. Another thing I want you to see is that you don't have to do the setup we did in this video every time you create a new project. Now all you need to do is to copy this .vs code folder in another project, and you will be able to do all the things that we do in this project here. So for example, if you wanted to create a new project, let's say we want to create a game, for example. Okay, we create a game here. All we need to do is to copy this .vs code folder, and it is going to be containing the settings that Visual Studio Code expects. So we can put that in here. And now we can drag and drop our game on top of Visual Studio Code and create a new project. We can create a new file, main.cpp, okay, and we can go in, include IO stream, for example, IO stream, and go into main. We have a main function here that we can use. Let's try to set up a variable. So let's say int value and give it an initial value of 5, for example. And print out the value. So std out the value, and it's going to print out the value. And if you want to build the project, we can do the things we did in the project that you set up. You can come to terminal, run task, and you see that these tasks are available for use in this new project that you just created. For example, you can build it using the CL compiler. If you want to debug, you can set up a breakpoint and hit F5. And your default debug configuration is going to be used, and you will be hitting this breakpoint here. So this is really cool. This is a configuration you can copy over to other projects that you create, and you don't have to set up a Visual Studio Code again. And this works. This is really cool. Now let's look at the benefits and the bad things about doing things the way I showed you in this video here. This setup is really simple. So you don't have to know a lot about C++ tooling. You can have a Visual Studio Code working, but the problem is that once you start having a lot of configurations, once you start needing to switch through IDEs, this is going to be really cumbersome because these tasks.json files that we saw are really a Visual Studio Code thing. You won't see other IDEs using these configuration files. So this is a thing that is going to lock you into Visual Studio Code. Another pain point is that it is really hard to bring in third-party dependencies. For example, if you want to build a graphical user interface application, you want to build a game using things like IntelliGUI and SFML, it's going to be really hard to bring those in. And this is going to bring you up to a point where you can do simple stuff with C++. But once you start wanting to move a level up, you will be using the tools that professionals use. Tools like CMake, VisiPackage, Conan, and things I am going to be showing you in the next few videos. So if this works fine for you, make sure you use this. But once you grow out of this way of doing things, make sure you watch the next video where I am going to show you how to use CMake to do things better than we did in this video here. Thanks again for watching this video. If you found it useful, please make sure to like, share, and subscribe. I am going to stop here in this video. I will see you next time.